Hello everyone, welcome to a short demo on quality of service supported in RBFS stack. Hierarchical COS allows service providers to make sure each subscriber service gets the network resources. Typically, QoS has building blocks which are classification, policing, queuing, shaping, scheduling, remarking. To brief about Rtbrick stack running on Qumran-MX platform, it's a distributed architecture based on microservices. Show process usage summary shows various daemons like PPOID.1, subscriberd.1, RIPD, FIPD, which are running on RBFS stack. These are called Rtbrick daemons, in short BDs. Depending on the scale and requirement, we can have multiple instances of the required daemons. It's a concept of sharding. Let me brief on QoS building blocks that RBFS stack along with BCM Qumran chipset supports. Classifier. We support BA classifier, MF classifier. BA classifier, a behavioral aggregate classifier, does classification based on code points in match types IPv4 TOS, IPv6 TC, IEEE 802.1 and MPLS EXP. MF classifier, multi-field classifier, does classification based on multiple fields in packets like IPv4, IPv6 prefixes, destination source L4 ports, IP protocol, IPv4 TOS, IPv6 TC. Polisher. We support 4-level polishers, where more than one class can be mapped to each polisher level. Type 2-rate 3-color polisher. Queue. Mainly to enqueue and dequeue different traffic streams that are egressing out of the interface. Queue size, which is configurable, allows to define the packets that can be enqueued. With respect to drop profiles, we support tail drop and WRED. With respect to WRED, it can be with different drop thresholds. Schedulers. To schedule queue based on scheduler type defined. We support strict priority, fair queuing, weighted fair queuing, and hybrid schedulers. Hybrid schedulers are a combination of strict priority and weighted fair queuing. Shapers. We support at queue level and at session level with defined high flow and low flows. Priority propagation is enabled globally. With priority propagation enabled, scheduler elements operate in dual mode with high and low priority flows. Credits from physical interface are consumed first by high flows and only remaining credits available for low priority flows. Composite enabling helps to differentiate between multiple low priority queues. Now let's see the topology that is built in our lab for QoS demo. As you can see, here we have Edgecore 5916 bare metal switch which has Broadcom Qumran chipset. For more specification on the device, please visit Edgecore website. The device comes with 10 gig, 100 gig links. Typically in BNG, the interface on which subscribers are expected to log in are referred to as access ports, which usually are 10 gig links. Core facing interface typically will be 100 gig links which attracts traffic from internet. In the current topology, IFP003 is the access interface and IFP004 is the core facing interface. In RBFS, all the physical interfaces are represented in the form of IFP. Once the subscriber logs in, we need to authenticate the subscriber. RBFS stack supports both local as well as remote authentication. In this demo, we would like to authenticate the subscriber via remote. This is typically done using the Radius server. FreeRadius is installed on the Linux container connected via IFP001. Let me go to the HQoS setup. The HQoS configuration very well says where this is the simulation of the Qumran-MX device which is connected to the PPOI clients over the access interface. The core facing interface are connected over the uplink interface. So these are the subscribers which are used for the QoS demo. Now let's move on to the traffic streams. The traffic streams are created both for upstream and also the downstream. Upstream with different VLAN priority bits have been created with 4 different flows, and downstream for different traffic streams like VoIP, VOD, Internet and other remaining traffics for which the 4 different streams have been created. Now let's see the demo setup for quality of service enabling on PPOE subscriber. Here if you can see the HQoS setup where this is the Qumran-MX device simulation to which on the access interface we are connecting the access device which are coming up with PBOE clients. On the core facing interface or the uplink interface we are connecting the server which is the simulation of internet traffic. Now let's move on to the device. This is our QMX device which is acting as the BNG. So now let's see the Radius user profiles. Here this is the user profile which we are using for the QoS profile activation. Here the important attributes that are needed like framed IP, IPv6, delegated IPv6 are defined for the user. Along with that, QoS profile is activated using this Radius attribute, Rtbrick QoS profile, which is configured with premium PBOE customer profile, the profile name basically. So now let's move on to the important QoS building blocks to activate that profile. Classifier component where we have configured with match type IEEE 802.1 with different code point to class mappings. Polyser component where we have defined all the 4 levels with CAR, PAR, committed bus size and peak bus size have been configured. Even we support max CAR and max PAR. So these two are the components with which we can do the upstream policing. So for the downstream, we are using multi-field classifier for the classifying of traffic. If you look at the multi-field classifier configuration, where 4 different classes have been defined and each class have been mapped to different source IPs from which the traffic is coming. So with MF classifier used for downstream traffic classification, let's look on to the queuing configuration where these classes are mapped to which all queues. So the VoIP queue is mapped to class 3, VOD queue is mapped to class 2, internet to class 1, like so. So the scheduler which is used for scheduling these queues, we will look to it. Here the strict priority scheduler is being used to schedule all the queues. Let's look at the scheduler mapping configuration where the different scheduler priorities have been mapped to different queues. If you look to it, VoIP queue has mapped to strict priority 0, which is the highest priority. Since it is a highly delay sensitive traffic, we are mapping it to high priority scheduler. Remaining other queues are mapped to different strict priorities. So if we look to the QoS profile, all the QoS building blocks have been mapped to this profile. This is the profile. Once the subscriber is authenticated, will get installed on the subscriber. So now let's move on to Ixia to bring up the subscriber. If you can see here, 2 subscribers have been come. So this is the subscriber on which the QoS has been installed, who is coming over VLAN 4011.11. Now let's move on to, as per the configuration, now the upstream policing and also the downstream shaping has to work. So before that, let's look at the QoS shaping configuration that we have defined. Here the VoIP queue is shaping at 4 Mbps and the total session shaping is happening at 20 Mbps. If you look at the VOD queue, this is also shaped at 10 Mbps. Here VoIP queue is shaping at 4 Mbps, VOD queue is shaping at 10 Mbps and the total session shaping is happening at 20 Mbps. Now let's look at the upstream policing, at what rate it will be policing. So as mentioned earlier, 4 different streams have been created and the traffic is started, and let's look at the what is the rate at which we are transmitting and what is the rate at which we are receiving. If you can see here, for all the 4 different streams we are sending at 10 Mbps. But if you can see here, the receiving rate will be 1 Mbps for level 1, 3 Mbps for level 2 and 5 Mbps for level 3 and 6 Mbps for level 4. So as configured, the policing is working. Let's stop the traffic and move on to downstream traffic. Now let's enable the downstream traffic where 4 different streams are there for 4 different sources. Like it's a simulation of VoIP source, VOD source and different web server traffics. Now since we have started the downstream traffic, let's look at the rate at which the different traffic streams are shaping. If you can see here, all the streams we are sending at 15 Mbps. And if you can see here, the VOD queue which we have configured as 10 Mbps, we are receiving at 10 Mbps shaping rate, and VoIP queue which we are shaped at 4 Mbps, we are receiving at 4 Mbps. We also support the stats with respect to policing and queuing counters. We can see for all the 4 levels we are seeing the police traffic stats. Mainly the green traffic, which is the confirmed traffic like committed information rate traffic. We can see the accepted counters or increment. And also we support queue counters also. If you can look at the same subscriber, we can see against each of the queue, the traffic is received, it is getting queued, and whatever it is exceeding, it is getting dropped. So the drop counter is also incrementing, queued counter is also incrementing, and received counter is also incrementing for all the 4 different queues that we have configured. With this, end-to-end flow of QoS for both upstream and downstream traffic for subscriber we saw in this short video. For any further queries, visit our website. Thank you.